Welcome to Study Loop.
This is the answer to Chapter 23, problem number 57 from the Smith Organic Chemistry textbook. This problem asks us to explain why each of these three reactions will not proceed as written. Okay, and so looking at A, we are trying to accomplish a decarboxylation here. So we're treating a molecule that has both a carboxylic acid and a ketone with heat, and we're hoping to decarboxylate it or get rid of the carboxylic acid. But one thing to take note of is that our alpha carbon is this carbon, and so our carboxylic acid, as it turns out, is actually on a beta carbon. And so the carboxylic acid needs to be on an alpha carbon in order for this decarboxylation method to work. So carboxylic acid is on beta carbon. Okay, and so that's why A is not going to work. Okay, and so then looking at B, we are trying to deprotonate diethylmalonate with sodium methoxide and then alkylate it using an alkyl halide. And the reason that this reaction is not going to work is because we are using a T-butyl, it would be T-butyl bromide. And so it's a tertiary alkyl halide. And remember, tertiary alkyl halides are not going to work for this reaction. And the reason that they're not going to work is because of steric. So tertiary alkyl halide is too sterically hindered. So too sterically hindered. So that's why reaction B here is not going to work. So then for part C, what we have is a deprotonation of an alpha carbon by LDA and then alkylation with ethyl iodide. However, when we're looking at these two potential alpha carbons here in the starting material, so we have one here and one here, and LDA is going to deprotonate the less hindered alpha carbon. So LDA will deprotonate less substituted alpha carbon. Okay, and so we're trying to accomplish this alkylation on the more substituted alpha carbon of our two alpha carbons here. So there are other ways that we could do this. We could use potassium terbutoxide and T-butanol, and then alkylate with the ethyl iodide. But LDA is going to deprotonate the less substituted alpha carbon, which would be the alpha carbon on the left. And so we would add our ethyl group to the other alpha carbon and not our desired alpha carbon. Okay, and so that's why reaction C doesn't work. And that is the answer to chapter 23, problem number 57.